All right, we're good? All right, thank you. So, DAS, small cells, and Wi-Fi, overcoming capacity constraints. So when we think about wireless, and when we talk to anyone in the community, we think about wireless in the sense of mission and life critical. And so one of the concepts, and we heard a conversation earlier today about, over the last 2 days, who pays for what, funding models, there's all sorts of things going on in this space. The one thing that we focus on, and we know that enterprise focus on, is this. Is the use of wireless in the enterprise critical to the mission? Whatever the mission is, i.e. how the enterprise makes money. In the case of a hospital, patient safety, satisfying patients. If wireless is critical to the mission, then who should own wireless? Who should own control and drive what's going on? Probably the folks who are using it for a mission and life critical purpose, right? And so if you think about an enterprise, and you think about other services or infrastructure that are critical to the mission of the enterprise, who owns that, manages that, controls that? Typically it's the enterprise, because it's critical to the mission. So the first thing we talk about, is it critical to the mission? If it is, then maybe we think about wireless a little bit differently than if it's not critical to the mission. So that's what we talk about. And we look at the wireless needs. So when we talk about the wireless needs, from a mission and life critical perspective, we talk about wireless voice over IP, we talk about location services, we talk about traditional wireless use of laptop data, we talk about smartphone data, right? We talk about enterprise communications. So all of these things are being used by the enterprise now to run their business, whatever that business is or their institution, right? So there's a variety of services that are mission and life critical to the organization. In addition to that, organizations are filled with people. They're filled with staff. And those staff are using those wireless devices for personal data and personal communications, right? And so we have to consider for those as well. And we also have what we call the facilities side, and that's where we pick up maintenance security. So we see a lot of wireless use for in-house security, in-house two-way radio, or in-house maintenance. And I think we just heard a presentation on public safety. So there are public safety mandates, and there's also a desire to simply have public safety. This Aria Hotel, this city center, has a full public safety system running on a single integrated DAS. It was very important when this property was built. We built in public safety throughout this entire facility, and it has it here as well. So we see that coming in as well. So the wireless is driving this facility operations. So there's a lot of pieces of the wireless puzzle from an enterprise perspective. So when we talk about it, we try to talk about it as comprehensive wireless. That's the concept that it's not just about cell phones, it's not just about Wi-Fi, it's not just about public safety, but it's about the totality of all of those things. And we look at outcomes. So the enterprise perspective is more about what happens when I use wireless, what does it do for me, how does it help me, and less so about the technology that's sitting in the IDF or the MDF. And so we put up a few of these to give you examples. For example, El Camino Hospital, 100% staff mobility and patient monitoring everywhere. So patients can have physiological monitors when 100% of that hospital can roam anywhere in that facility. That's critical to the mission of that hospital. VCU increased 4 times the floor space with the same number of nursing staff in a new critical care tower, all enabled through mobility, through wireless. So again, just good examples. I won't go through all of these, but you can read them as well. So when we talk about a comprehensive view of wireless, what we mean by that is it's really Wi-Fi and DAS both working together. And the reason we say that is we start to look at the mission and life critical pieces of it and the staff satisfaction on the facility side, that there are various wireless services. So when we talk about Wi-Fi, we're talking about obviously 2.4 and 5 gigahertz Wi-Fi. We tend to think of it as there's 3 uses of Wi-Fi, potential use of Wi-Fi in an organization. One is guest, right? So how many of you are logged into the ARIA guest network right now, right? So we're using the guest net, probably pretty much everybody in this room. Then there's enterprise. So enterprise is where Wi-Fi is used to run the business. So it's the running up in a hospital, it would be the laptops, it would be the mobile carts, it could be radiology systems. In an enterprise, it could be laptops and others. And then in the 3rd level is for hospitals only, and that's what we call clinical critical. That is where Wi-Fi is actually used in the delivery of patient care. devices, things actually connected to patients, delivering patient care. So the question to ask, and the perspective of the enterprise is, should all of those be treated the same? Do they have the same criteria? Do they have the same requirements? And the answer is most likely no. There are different requirements for the different types of use of wireless. And so we think about it that way. Then over on the DAS side, again from the enterprise perspective, it's all about 3G, 4G, pretty straightforward. We've had 2 days of talking about 3G, 4G types of technology. I think everyone understands what the use of that is. However, I'll give you an example of a hospital in Texas that was so concerned about their Wi-Fi network that the guest use consuming the Wi-Fi network would inhibit the use of the Wi-Fi network for enterprise and clinical support. So they throttled back the guest service on the Wi-Fi, right? A lot of things in a restriction policy. There's a whole bunch of things you can't do. And they said, instead of saying, here's how I'm enabling what you can do, it's all about what you can't do. So their view is, the DAS is the guest net. Because if the DAS is the guest net, use the cell phones, you all got your smartphones, you can access anything you want to access on your own data plan, stay off my Wi-Fi network, right? So that was their way of thinking about and preserving this criticality nature of the Wi-Fi. So they think about the cellular network, the DAS network, as their guest network. And then, of course, in public safety, we talk about public safety and two-way paging, etc. We talk about that a lot as well. So when we think about wireless, and when our enterprise customers think about wireless, they think about their use of wireless and how they use wireless. And it's really not about the third-party operator or the carrier. It's really about what does it mean to the enterprise, right? And so we talk about, here's where we sort of kind of get down into the nitty-gritty. From an enterprise perspective, it's really not about the network or the equipment or the small cell versus DAS versus this versus that. It's about the device, the need, and the plan. What device is used for what service is critical to the mission, and then which network is it best to run on. So that's what we think about. So, for example, when we talk about mission and life critical types of applications, we have laptop data, high data rates and volume, and mission critical, right? So we're sending a lot of data, we're transferring images and what have you, and we've got mission critical. Then we talk about location services, periodic traffic, but it needs a lot of coverage, right? I got to know where things are when I'm doing location services. And we talk about wireless voice over IP, so wireless handsets running on the Wi-Fi network. Periodic traffic, but high volume and very critical. What happens when you drop packets on a VoIP? Disconnected call, right? Unacceptable, right? So we have different types of use. Then we talk about, over on the DAS side, on the facility side, we talk about cell phones, equivalent support, all carriers. We're big believers in neutral host. The BYOD phenomenon, if we're talking about enterprise use, we're talking about hospitals, we're talking about universities. We heard it this morning. I need all 4 primary carriers. Right? I'm no longer able to dictate that it can only be AT&T, it can only be Verizon. I need all the carriers. And that's both for my mission and my critical use of BYOD, and it's also for the personal use because I don't dictate to my employees what service they're on. So, our company, we used to have a corporate plan with those old, cruddy Blackberries, and we went to a BYOD. So I chose a given carrier A over carrier B. And why did I choose them? Because I get to put an expense report in every month for X dollars, and by joining my wife and kids' family plan, that kept me under those dollars. That was my criteria, right? So we're making decisions on what service to use, and that's nothing to do with the enterprise, right? Our enterprise contracts with carrier B, but I made that decision based on what was right for me, and so I want that service to work. So we see those kinds of phenomena changing as we go through the process. And then when we talk about facilities, we kind of put this in the optional support category. When it's new construction and we have a public safety mandate, it's no longer optional, and I think you heard that from the previous speaker. But we also have the ability to support two-way radio, paging, etc. I'll tell you a quick story about, again, this property. When they built this property, they had a multi-million-dollar budget for two-way radios for maintenance, security, and what have you. And they saved that money, and they're actually using the cell phone network for all their in-house maintenance, security. There's no two-way radio in all of City Center. So they're actually using cell phones to do that, right? So they were able to make that choice about how they handled that inside this facility. So that was a very important consideration when they built this DAS inside of this property, right? And then when we start talking about smartphone data, now smartphones present another interesting challenge or opportunity. With a smartphone, mine sitting back here, I can run that smartphone on the cellular network, I can run on the Wi-Fi network. Who chooses? Right now, in a lot of cases, and I think somebody said it yesterday, in a lot of cases, the device is making the choice, right? There's priorities, right? In other cases, the network is making the choice. But in an enterprise perspective, who should make that choice? Maybe it's the enterprise, right? And so when we start talking about the use of smart devices that have the ability to access multiple networks, that gives the opportunity for the enterprise to make decisions about that. So we heard a conversation yesterday about small cell technology that includes Wi-Fi that says, okay, I'm going to go to whichever network is the strongest. Right? If the Wi-Fi drops off, I'm going to jump on the cell and vice versa. Who's making that choice? The network operator. Who owns the Wi-Fi network? The enterprise. Who's making the decision about who gets the bandwidth? In that case, the network operator or the technology. Is that where the decision should be, right? So these are the kinds of things that we consider for when we start talking about these integrated networks, right? And so our perspective is, and we think the enterprise perspective is, let's pick the best network for the device, the application, the need, i.e. the mission of the organization, right? So when we look at the options, and this is where, again, we think the enterprise, where wireless is mission and or life critical, has a choice and wants to make choices, and this is where we believe that the ecosystem, which is the OEM manufacturers, it's the network operators, and it's the third-party operators, we all have to be on the same page here. So, for example, we have our traditional active, hybrid, coax, fiber DAS, right? That DAS, and you've seen that technology, it's all sitting in the room next door, and we call that an island, right? It's a DAS, and that's all it does. Right? It doesn't do anything else for the enterprise. It's a DAS. It supports the cell phones. It can support two-way radio. It can support public safety. It can support paging. All of those things, but it's a DAS. It does nothing else for the organization. But now we've got new technology that has the capability of doing more than DAS. We have convergence technology. So, for example, we can now put an active element out of the antenna site, up here on the ceiling, and out of that active element that's doing DAS, cell phone, etc., I can plug an access point. And I'm sharing, right, the physical infrastructure that got the signal up there. So now from an enterprise perspective, maybe I'm interested in that. If I'm building a new building, and I'm pulling category cable all over the place, and I'm pulling fiber all over the place, I'm putting a DAS in, I'm putting a wireless LAN in, I'm putting all this infrastructure, maybe I want to converge that onto some common platform for a number of reasons. Economics, technology, etc. So we start to see this trend happening. So we have a choice now in this area. And then we come to the third area, and this is what a lot of us talked yesterday, we start talking about small cell and Wi-Fi, integrated small cell Wi-Fi. So this type of technology. So I can now use a DAS, I can use small cell, and I agree with a lot of the comments made yesterday. There's a big gap when we talk about building size, 50,000 square feet, up to 200,000 square feet. What's the answer? What was the guy yesterday? Please send me your small cells. Right? We need an answer, but the answer is 25% of where it is. Doug, gas is expensive. It is. This stuff is expensive. But if wireless is critical to the mission, I've got to spend the money, right, to make it work. But I've got choices of technology, and if I go this route, I'm going to have multiples going down that hallway, whereas a DAS gives me neutral host. So I've got choices here. And the enterprise has different perspective on those choices than do the third-party operators and the network operators, right? Based on many, many factors. So again, those are important things to be considered for in working with the enterprise. Right. Now, what we do know, though, is when we talk about this stuff, when we talk about DAS, small cell, it's about coverage, capacity, and a third C, criticality. And so we call it the 3 Cs. So 5, 6 years ago, it was all about coverage. 3 years ago, it was about capacity. And today, it's about criticality. So this is all happened in the last 5, 6 years. And so we believe, and we believe most enterprises believe, that it must be equal support for all carriers, but one design. Right? So if I'm designing the wireless infrastructure, I need to do it one time, but for all carriers. And it absolutely has to meet carrier criteria. So one of the things that is not going to change is we need to meet Paula's requirements. We need to meet Scott's requirements. So absolutely on the cellular side, the carriers drive what that needs to be. I think Paula yesterday used the word trash systems. No trash systems, absolutely agree. So we've got to make sure we maintain the dominant signal, etc. We've got to make sure we've got the right capacity to match the sectorization plan of the carriers, etc. All of that is absolutely critical, whether the enterprise owns the DAS, or whether the third-party operator or the carrier owns the DAS. So that does not change, absolutely has to be there. Obviously 911 as well. So it's got to be, and the key part of that also is coordinating with the carrier. So when an enterprise owns the DAS, then there's a very, very strong area that gets overlooked, and that is that area of carrier coordination. And I think the previous speaker talked about, get a good integrator. Yeah, get a good integrator. You need help. Right? There's a lot of work to be done there. You need a good integrator to do that. So we're a good integrator, so we'd like to say that. So when we talk about wireless LAN, I'm going to shift gears a little bit and talk about wireless LAN. Now, in wireless LAN or Wi-Fi. So in Wi-Fi, the world is changing as well. So again, when we keep that theme of coverage, capacity, and criticality, we think it has to do with a lot with data rates, with traffic types, volume, density, user priority. Again, when we're designing a Wi-Fi system, it's about we start with the devices and the users and the physical location and the workflow and where they are, and then work back into the network. And so we have a traditional Wi-Fi network, right? For those of you who noticed it, the Wi-Fi network in here is sitting back on that wall back there. The Aruba access points plugged into the wall supporting this room. Well, that Aruba access point over there has to support everybody in this room equally. It's got 2 radios, 2.4 and 5 gigahertz, and it has to support all of us, and it goes down to the lowest common denominator, right? And that's standard traditional AP on ceiling, and in many enterprises, that's good enough. That's all we need. But in many other situations, we need more than that. So again, we come back to this concept of combination small cells, right? Where I'm going to hand off, offload carrier traffic to the Wi-Fi. Who's controlling the quality of service? Who's controlling the capacity and who gets the capacity, etc. When I've only got 2 radios sitting there, I don't have a lot of choices. Right? So we believe very strongly that Wi-Fi can be deployed, should be deployed in another fashion, and that is by putting in multiple simultaneous wireless LANs, either for just raw capacity. And so you see a picture here where I'm showing 1 2.4 Wi-Fi and 3 5 gigahertz Wi-Fi. So we can deploy in this room 3 independent 5 gigahertz wireless LANs that have nothing to do with each other. They can be completely managed separately. So when we start to do this, and I can do that just for raw capacity purposes, so if I've got an environment where I'm doing a lot of carrier handoff to Wi-Fi, etc., I may just want raw capacity. Or from a criticality perspective, I might look at it a little differently. So here's what I do. So the device and applications drive the design. We still drive to the appropriate signal level. We've got to meet the minimum signal level, minus 67, for voice over IP, etc. We want to deal with all the airtime requirements and the overall capacity, and we map out our access points, right? So we've got my coverage plan here, and I've got my 2.4 and 5 gigahertz radio. Then what I do is I'm able to add additional access points. You see the picture kind of built there. You see those coverage circles, and you see 2 more access points in each one of those coverage areas. By properly provisioning those access points, I can deliver 1 2.4 layer and 3 5 layers in the same coverage area without interference. I can then use them either for raw capacity, running any applications, but here's what our customers do, and we've got hundreds of them doing this. When we start talking about the criticality, if I now go back to that comment I made earlier about different uses of Wi-Fi, guest, enterprise, mission or life critical, I might want to take those wireless LANs and allocate them based on those 3 criteria. So I might have guest critical on its own layer, and it gets the entire bandwidth of that radio and that access point, and doesn't worry about anybody else. I've got a layer for mission or enterprise critical, and I don't worry about anybody else. And I've got a layer for life critical, about my life critical devices. So I may have life critical devices. By the way, the life critical devices in the hospital typically don't use a lot of bandwidth. There's not a lot of data going back and forth, but it's life critical and you don't want it impinged. Now, one of the things that we do, we do a lot of wireless Wi-Fi assessments for existing Wi-Fi networks. We are seeing in a traditional Wi-Fi network in hospitals that 70 to 80% of the available capacity of the Wi-Fi network is consumed by the guest net. Consumed. And as I think somebody had stats yesterday, and yeah, it's Apple 4-to-1, right? Then Samsung, then everybody else, right? And so the concern is that, and it's just like that concern in that hospital in Texas, if the guest net is eating, if I only have these 2 radios, and the guest net's eating up all that capacity, and I've got enterprise and life critical applications contending for that, I'm not sleeping well at night. So by doing this, I take that all away. Now, it's not on the slide, but one other thing we can do here. One of those layers could be a carrier layer, could be a macro offload layer, or it could be a small cell handoff layer, where I hand off that traffic to a Wi-Fi layer and isolate it from the rest of the enterprise traffic that's critical to the mission of the enterprise. So again, a little different way of looking at Wi-Fi. Now, so here's what's happening. This is real world. This is an actual one of our customers in California, and we did a study 3 years ago, and we did a study just this year. And so what you see here is what's in yellow is the guest net. So they've had a 1,000% increase in guest use, carrier offload, in a 3-year period. But if you look at the sort of red and blue, right, that's their enterprise and their life critical layers, not impacted one bit. They continue to operate because they're completely segregated inside the organization. So this is where we see the capacity issues. And quite truthfully, the traditional answer in Wi-Fi about capacity is if I got that Aruba access point back on the wall and any more capacity, put more of them closer together, right? Doesn't work. More of them closer together raises the noise floor, it's more interference, throughput actually goes down, right? So we've got to get capacity by putting more channels in. The cell phone industry knows that. Capacity is channels. That's how you get true capacity. That's what we do here. So the other thing that happens when we talk about comprehensive wireless is the design. And so one of the opportunities from the enterprise perspective is I've got to design the cell phone network. I've got to design the public safety network. I've got to design the Wi-Fi network. Why don't I just do it one time, right, and do it all? So one of the advantages that all of us from the cell phone business, DAS business have, is that we use very, very good predictive design tools. Ivy Wave guys, raise your hands, right? Very good. What do we use in the wireless LAN space? Right? We use lesser tools. And so the tools from a predictive perspective are not good enough. So what do? We walk around with an AP on a stick and take readings because that's the only way we can do better than the tool. The reality is the Ivy Wave type of predictive tool is the best tool to design Wi-Fi. And when we sit down and we format those floor plans, we build in the wall types and so on and so forth, that design effort is equally applicable to cell phones as well as to Wi-Fi. So use those tools and do that. So, and here's what happens. So if you use that tool, there's different ways to use the tool. So if I use that tool and I do not format the walls, I put in my radiating elements, and that heat map looks really, really good. Doesn't matter if it's cell phone or Wi-Fi, it's just a heat map. It looks really, really good. So I have our engineer, then I sit down with the engineer and I say, okay, let's put in the walls in the hallway. All right, still okay, right? But it's not a signal. Then we sat down and said, let's format in all the walls with the coverage walls, right? So then let's put the RF elements, the antennas, the access points, where they really need to be. So the design went from 4 or 5 radiating elements to a dozen radiating elements to get the signal where it really needs to be when you format all of the walls in the facility. Right? And so this design criteria, and it has to be done both for cell phone and for Wi-Fi. And when we do this, so now we start talking about, and you can kind of see this here, we're showing a little checkerboard here. If we're going to use DAS and Wi-Fi, pretty straightforward. If we're going to use integrated small cells that support small cell and Wi-Fi, okay, where do they go? And is the coverage pattern the same for the cell signal as it is for the Wi-Fi signal? So what I'm going to do is I'm going to deploy small cells with Wi-Fi modules here or cell modules there. So I have to design for that so that wherever I put the radiating elements and I drop those modules in, that I get equal coverage on that floor for all the signals. It's a real design challenge. The right way to do it all at one time with the same tool, right? So that's our message, and that works very, very well when it's done this way. And then what we get is we also maintain our best server plots for the Wi-Fi. Because with Wi-Fi, the one thing we have to worry about that we don't really worry too much about on the cell phone side is we've got to be able to hand off between the coverage areas, right? We don't want those VoIP phones dropping calls, etc. So we've got to deal with all the best server plots, etc. So very complex when we do this, and our argument is do it once. So, and then of course there's the validation. So anything that's deployed must be validated. We must meet all the validation criteria of the network operators and third-party operators, but also of the Wi-Fi network. So again, all of that can be done through a series of tools through a single validation process as well. I came right up on zeros. Thank you for listening, and I'll take any questions if we have